These are your 1-3 notes on properties of numbers. These are all of the mathematical rules answering why are we allowed to do that. It's the why part of anything that we do involving equality. So the first thing I want you to understand is that properties is just a fancy math word for rule. So these are your equality rules. These are the names of the rules that things that you've been doing and you know are true. You probably just never knew what they were called or why we can do it. So the first one is the reflexive property. And this is a property that allows us to say that something is equal to itself. So in symbols, I might say that A is equal to A. Pretty straightforward. It's kind of common sense. But now we have a name to say why this exists. Not so important in Algebra 1 as it is in geometry. You're going to see all of these again in geometry. Okay, so an example of this is that 3 is equal to itself 3. When you get that answer, you can say, well, that's true. And someone might say, well, why is that true? And you say, because the reflexive property tells me it's true. I know it's sort of a common sense thing, but it does happen. And you're going to see more use for it, again, in geometry than you do in algebra. I know many of you use the symmetric property every time you solve an equation. Okay, so if one quantity equals a second quantity, the symmetric property then says the second quantity equals the first. Basically, in symbols, if A equals B, then you're allowed to say B equals A. And all I did there was just flip-flop sides. So if A equals B, I can change it and put the B on the left side and the A on the right side. Now, where have I seen you guys use that? I bet you've used it with if 5 is equal to x minus 3, then x minus 3 equals 5. Many of you like to solve equations when the variable's on the left-hand side. And so I know you probably asked your teacher, hey, is it okay if I just switch these around? I like my variable on the left-hand side, and the answer is yes. In equality, if they're matching, if they're equal, it doesn't matter what side they're on, as long as when you flip them, you keep them the same. The transitive property is the long one. Okay, there's 3 things to the transitive property. So we're no longer talking about 2 quantities, we're talking about 3 quantities. So we'll have like an A, B, and C. And the transitive property basically says we could just skip over the second quantity. So what this says, if you have first equal to second and second equals third, then through the transitive property, we can say that first is also equal to the third, even though they weren't set equal to each other in the equation. So this says if A is equal to B and B is equal to C, then that implies that A will eventually equal C. There's 3 things transitive. Think of T3. It's the long one. So this is something I do here, and it might make sense. If 10 is equal to 2 times 5, and 2 times 5 is equal to 5 plus 5, then we can say that 10 is equal to 5 plus 5. So notice what I did there is I took the first quantity, set it equal to the second. Here's your A. Here's your B. Then I took the second quantity, B, and set it equal to a third, C. And in the end, we said A is equal to C. So it sort of just eliminates that second quantity. The second quantities kind of cancel out, and you're left with the first and the third. Substitution property. Much of what you've done all through elementary school was a substitution property. Replacement. Okay, so what you're doing is if A is equal to B, then A may be replaced by B in an expression. So it's kind of hard to see because it's sort of one of those common sense things again. In symbols, well, there really are no symbols there because it's already in the definition. So let me give you an example, sort of going off of what we just did up above, or in order of operations. So if I have 2 times the quantity 3 plus 4, that's equal to 2 times the quantity of 7. And what I did there, what changed, is I replaced 3 plus 4 was 7 because I know they're equal. I know that 3 plus 4 is equal to 7, so I replaced it. The rule that allows me to do that is substitution. Now, I know I broke my rule of working down the page, but what's going to happen in this section is they're going to give you a bunch of these rules, and you got to identify it. So you're going to match it up, and you say, okay, well, the 2 didn't change. The only thing that changed from the left to the right side is we went from 3 plus 4 to a 7. What allows us to do that? Sorry about the bells. Okay, then we have properties on identities and inverses. So you have to understand what those words mean, or this isn't going to make sense to you. Again, I'm throwing a lot of information to you guys. I'm just exposing you to it. We're going to work through some things in class to really get good at these. I know there's a lot of information, but if you can break down the vocab, it makes sense. An identity is who you are. So in math, an identity is who a number is. So identities are things that occur to numbers that don't change their value. There's 2 types of identities. There's additive identity and multiplicative identity. And then inverses are the opposites. So there's opposites in addition, and there's opposites in multiplication. So an inverse. So additive identity is 0. The additive identity is 0 for any number a. The sum of a and 0 equals a. And so what they're saying here is just that. It's the rule that allows us to say when you add 0 to any number, it's going to stay the same. It keeps its identity. So an example of that would be 5 plus 0 equals 5. What allows us to say that statement? The additive identity. The additive inverse takes us to the identity. So it's the number that you add to a number that takes you back to 0. And so it's called the opposite. The additive identity is the opposite. So if I have a and I add the opposite of a to it, it will take me to 0. It cancels each other out. That's called the additive inverse. So if I have 5 and I add negative 5 to it, I will get 0. The multiplicative identity is the number that you multiply by, and it keeps the numbers equal to itself. So the only number that you can multiply by a number by and it equals the same number is 1. So if I do 1 times a, I'll still get a. So 1 is the multiplicative identity. It keeps the value of the number. 5 times 1 is equal to 5. It didn't change. That's the multiplicative identity. The multiplicative inverse takes us back to the multiplicative identity. So it's what you multiply a number by to get 1. And so what this is saying here in so many words, you multiply by the reciprocal. So we don't change the sign for multiplicative. We flip the number. For any number, there is a reciprocal such that the product of the number and the reciprocal is equal to 1. So if I have an a value, if I multiply by the reciprocal 1 over a, those a's in the numerator and denominator would cancel and you'd be left with 1. If I have 5, if I multiply 5 by 1/5, it will simplify to 1 whole. And then there's one more kind of just out there, but it's the crazy rule of 0. And you know, and everybody knows, that when you multiply a number by 0, it just equals 0. And why is that? Because of the multiplicative property of 0. So again, we're just giving everything a name as to why it happens. Anything multiplied by 0, in fact, equals 0. 5 times 0 is equal to 0. Why? Because of the multiplicative property of 0. Rather than just saying, well, just because, I don't know, that's just the way it's always been, we have an actual name for the reason why. 2 more properties, I swear, and then we'll be done. These 2 we use all the time, and you probably don't even know it. Okay, all of these we use all the time. Commutative property involves the order in which we add or multiply. It does not change the sum or product. So we rearrange things. We rearrange how we add numbers. We rearrange how we multiply numbers. I do this all the time. In symbols, this is basically saying that A plus B is equal to B plus A. Now, I know you look at that, and what's confusing is the commutative property looks very similar to the symmetric property. The only difference is I have the same exact numbers on each side, just flip-flopped within the side. Their order changes. So this is the rule that says 2 plus 3 is the same thing as 3 plus 2. Or in multiplication, 2 times 3 is the same thing as 3 times 2. They both work every single time. The associative property is your grouping. It's the way that you group the numbers together when you have more than 2 numbers to add or multiply. So it's talking about larger groups of numbers. You have 3 or more. You get to choose. Do you want to add, which 2 do you want to add first? The associative property says it does not matter. These are only true for addition and multiplication. So what this is saying is that I can take A plus B, then add C, and it'll give me the same thing as A plus B plus C. So notice I put the parentheses around different quantities. The parentheses in the order of operation says on the left-hand side I got to add the first 2 numbers together, then add C. On the right-hand side, I'm going to add B and C together first, then add A. And what the associative property is saying is you'll get the same answer regardless. Okay, and the same thing is true for A times B, then C is equal to A times the product of BC. So look for the grouping. Parentheses group things differently. That's the associative. I could also put under the commutative A times B is equal to B times A, just flipping the order of the numbers there. So an example in the associative property, maybe I want to, I do 2 plus 3 first, then add 4, and that would be the same thing as if I had 2 plus 3 plus 4 in parentheses. Notice the numbers all stayed the same order. 2 is first on each side, 3 is in the middle, and 4 is in the end, but my parentheses changed and grouped them differently. In class, I'll kind of go over an example as to where we use this all the time and we don't even know that we're doing it. So when trying to identify the property used in an expression, we're going to look for changes from the left of the equal sign to the right of the equal sign. So you say, what changed from the left to the right? You compare things, you look. Did the parentheses move? Did the numbers move? What do I got? Did something turn into a 1 or a 0? Or did the numbers stay the same? Look for changes from the if to the then. It's kind of like the before and after. So left is your before, right is your after. If is your before, then is your after, and then you can name the rule. So those are just some key things. These do get a little confusing because so many of them are alike. I'd like to maybe go through these together in class. These notes were kind of long today. So we'll go through these together in class. What I'd like you to do is I'd like you to, let's evaluate this one together, and then we'll go from there. So we'll go through the other ones in class. So using the order of operations here, I need to do parentheses first. I can do these parentheses, and then I can also do this portion of the parentheses here since the parentheses are separate. So I'm going to have 1/4, and 12 minus 8 is 4, plus 3. 15 divided by 5 is 3, minus 2 in there. And the property that I use there, really, what allows me to say that 12 minus 8 is 4, and what allows me to say 15 divided by 5 is 3, is substitution. I used the substitution property to carry out that math because I just replaced a value. So I know it gets tricky because we probably could use substitution over and over and over again. So you're going to try to have to, if there's something better, use something better. So in this next instance, why don't I go ahead and clean up this 3 minus 2. And so I'm going to have 1/4 times 4 plus 3 times 1. And that also is substitution because I know that if you take 2 away from 3, it just equals 1. Okay, and then I'm going to multiply. I can do both multiplications, but I actually want to keep them separate because they're different rules. So when I take 1/4 times 4, I notice that they're inverses of each other. I know that 1/4 is the reciprocal of 4. And when you multiply 1/4 and 4 reciprocals, you get 1. So I'm going to do that first, and I'm going to tell you that that right there was the multiplicative inverse. And I'm going to give you guys abbreviations to these in class. So the multiplicative inverse took me back to 1. It's multiplying, okay? So that throughout the, I couldn't use additive there because I was multiplying, so that's a clue too. And then 3 times 1 is 3. Now again, I know you could use substitution in all of these, so you always want to look for something better than substitution. So 1s and 0s are always, if you get a 1 or a 0 as an answer, or you see 1s and 0s in the problem, you probably could use like an additive or multiplicative identity or inverse. When I multiply 3 times 1, I get itself. That is the multiplicative identity. The rule that tells me I can multiply by 1 and I'll get the same number is the multiplicative identity. And then my last step of this whole problem is adding 1 and 3. I get 4, and that was just good old-fashioned substitution. I know there's a 1 in that problem, but it really didn't have anything to do with identities or inverses. We won't do a ton of these, but it's good to break it down. It's good to justify your answers and understand because it gets you ready for when we have to do that later on. So what I'd like you to do is name that property. Try doing what I just did in the example, okay, with this particular problem. I should see, I think, 3 to 4 different steps with the justification next to them. Okay, and then we'll go back through and we'll answer those other questions in class. Good luck.